Start over. Find iron on your periodic table. Iron is a transition metal. Let's just look at the outer electron. So what are we in the fourth period? Is it 4s2? So we have, oops. You don't have to write this part down. 4s2, 3d6, correct? Okay, so if I were to write the orbital diagram, this is my 4s. And again, just follow along on this is all. I'm just trying to explain to you how an atom or an element can have more than one charge. So, in order, iron actually can have two different charges. It can have a 2+ or a 3+ charge. So I'm not going to expect you to be able to do the orbital diagrams. I'm just showing you why it can happen. In order for it to have a 2+ charge, it must lose 2 electrons. It likes to vacate the upper energy level. It actually likes to vacate the 4s2. So when it becomes a +2 charge, I could zoom in on that a little bit more probably. It's going to vacate these two 4s electrons, and it'll have a Fe with a 2+. When it wants to become the 3+, it will get rid of this last one so that each of the d orbitals have 1. And we say that it has more of a stable arrangement when they all have 1. You could talk about it's got a lower energy, potential energy, whatever the case is. I'm just trying to show you how it could have either a +2 or a +3. You don't need to be able to duplicate that. I'm just so that you understand what the reasoning is behind that. So I wish this was a different color. I thought it would show up a little better, but it doesn't. Kind of let that get in there. This is a periodic table of all the ions. You're familiar with all these being +1, +2, the -3, -2, -1. So if we're just going to focus on these other metals here, many of them only have 1 charge. Again, you're not expected to memorize them. But I do want you to write down and be familiar with those 4 that I've highlighted. So iron can have a 2 +2 or +3. Write this in your unit packet. Write this down. You should have that out. So iron can have a +2 or +3. Copper can have a +2 or a +1. And then tin and lead could either have a +2 or a +4. So I want you to become familiar with those 4. Those are the ones you are going to see most of the time. And those are the only ones that I will put on the test that I expect for you to know that they have different charges. You don't have to memorize the charges. You can figure that out. I need you to know that iron, copper, tin, and lead have more than 1 charge. Okay? Iron, copper, tin, and lead. Again, you don't have to memorize what their charges are. Just be able to know that if you see copper, oh, I'm going to have to address that issue. This is a +2, +3. This is just a +1 and a +2. I thought that this is the color that I have. I thought I had some with the white background, but obviously I don't. Okay, so why do we really care or whatever? So what we have to do in these that have more than 1 charge is we're going to have to figure out what that charge might have to be. So you already have an example. They give you an example where tin has a +6 charge. Okay, I'm not sure where they got that from, but that's what they're trying to show you. So it says if it gave you an example of SnO3, how would I know what the charge is on tin? Well, do we know we have 3 oxygens? Do we know the charge on each of those oxygens? So if I have 3 of the oxygens and 1 of the tin, if this is a -6, this has to be a +6. The whole thing has to be equal to 0, right? The whole thing has to be equal to 0. So the only way for this for 1 of these to cancel out 3 of these is if this is a +6. Let's do that with iron. Let's say you are given a formula Fe2O3. And they're asking you to come up with a name for that. Well, you recognize, stay with me, some of you are already fading off. I recognize iron is one of those that has more than one charge. I have 2 Fe's. I don't know the charge of them. I don't know if it's a 2 or a 3. And I have 3 oxygens. But we do know the charge on the oxygen, right? It's a -2. And I know the whole thing has to equal, or 0. The whole thing has to equal 0. If this is a -6, and I have 2 of these, it has to be a +3, doesn't it? So we have to determine what that charge is. They're not going to give it to us. And then the name on it then would be iron. And then we have to write the charge so you can tell the rest of your chemistry community the charge. We're going to use a Roman numeral 3, iron 3 oxide. So the only thing that has changed is you telling everybody what the charge is on that iron. Yes, ma'am. Yes. Okay. So that Roman numeral tells me the charge on the metal ion. That's all it tells me. It does not tell me how many I have, which a lot of people start making that mistake. So then let's do the reverse. Let's say I have, they give me copper 1 oxide. And they ask me to find the formula. Well, this tells me now my copper has a +1 charge, or 1+ charge. My oxygen has a -2 charge. The whole thing has to equal 0. So what am I going to add? I have to add another copper, right? So what's the formula? Cu2O. Okay. So it's more of like, you could think of it as reverse engineering. I know the formula. I know how many of each I have. So I'm going to come up with the charge. Okay. Or they give me the formula, and then I know it has to equal 0. So, the name. So either way, you should be able to do that. So let's turn to the next page. Number 3, what is the name of SN2O3? And I know you probably don't have a lot of room on your paper. Is it? Yeah, some of these copied differently, sorry. So, what is the name of SN2O3? So, what did we just do? We basically threw a bunch of these together. SN, SN, O, 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 -2, So tin has to have what charge? It has to have a 3. Which isn't like what I showed you, so is that right? It's right, but it's not what you wrote down, right? So again, I'm taking what somebody used from last year. Sorry, it's a poor excuse. I didn't work through all these. We won't throw you off like that on the test. But if that's what we gave you, you still got to come up with it, right? So the name is what? Tin numeral 3 oxide. Okay? Even though it's not one of your choices. So don't go to memorizing. Just know that tin is one of the ones that has more than one charge. What about the formula unit for silver 3 nitride? So we have Ag is a 3 plus, N is a 3 minus, so it would just be AgN. So what I think they did in here, just to kind of give you a lot of different practice, is just made some up. Silver does not take on a 3 plus charge. I'm not going to say it never can happen because there's always possibilities, okay? What we wrote down and looked at were the most common charges for tin, most common charges for iron, that kind of thing. So I want you to work on numbers 1 through 12 with the remaining time. Well, we did number 1, right? So we'll just work on 1 through 12 for right now. Coming up with those names and the formulas. You might bounce back and forth.